actually a graduate from the Master of Science in Data Analytics from our, let's say, from the beginning of the program, is from the first group of graduates in the program, and already he decided to join us and is teaching assistant in the program. So this is the best, let's say, way to say what we are doing in our program and how we engage people and how they grow in their profession and try to stay engaged with us. Before turning the mic to our presenter, I want to tell you about some logistics. So the internet to use is the guest internet. There is no password needed. You just need to accept the terms and conditions. And in order to remain without kicking you out from the internet, you have to remain active. That means doing something. If you remain not active for more than 15 minutes, you will be kicked out. And just in case, like with any technology, as much as you can save your work, because we are going to do hands-on experience in the data science experience, as much as you can save your work is, of course, recommended. You already know that as a professional working in this field. With no more, I would like to give the word to our presenter. And another presenter, which I have forgotten, she's going to work in the demo we are going to do, is also our graduate and teaching assistant in the Master of Science in Data Analytics, Yelena Batenskaya. And both presenters, LinkedIn, let's say, short resume is in the invite. With no more.
Thanks, Samar. Okay, good evening, everyone. Everybody able to hear me there? The end corners, we good? All right. Okay, thank you and welcome to this meetup. And thanks, Elena, for the lovely introduction. So just one more piece to add in there. I'm also the organizer of one of the largest data science meetups in New Jersey. So anyone here close to New Jersey and what you like to continue learning about data science and, take advantage of all the opportunities that we offer in that meetup. It's called the Central New Jersey Data Science Meetup. We are 1,200 plus members, data scientists kind of meetup group that meet on a monthly basis. So that's one more piece to add, and let me know. I can always connect you with that meetup, being the organizer of that meetup. So with that, let's see the agenda today. So we'll be talking about mainly on the data science experience, right? And we'll start the conversation with IBM Watson Data Platform, on which the DSX, which is, DSX is the data science experience in short, and then kind of get into knowing a little bit about DSX, and most of the time will be spent on doing some hands-on, right? That's what we really want to do here. In data scientists, we really want to get hands-on, and after knowing a little bit about the tool, let's make use of this tool, okay? So just a little disclaimer before we get into our presentation here. The slides that are used in presentation are actually just brought together from different IBM presentations on IBM DSX. So I don't work for IBM. As Elena mentioned, I'm part of telecommunications, been working for AT&T. So this is really like bringing together some of the slides that will really will be helpful for our day-to-day here, for our evening today. So just kind of making it short. So we don't want to take any credit for building this slide, but as for UMEC, we kind of just brought this together. Okay. So what is IBM Watson Data Platform? Okay. So Watson Data Platform is an environment or a platform that is built by IBM, of course, right? And it's what connects the users to data and analytics. And it's built upon the Spark Analytics operating system, which, as many of you may already know, it's one of those tools that were developed or this OS being developed as part of Apache project. And like any other companies, in this domain, a data science arena domain, IBM too has embraced and is kind of fully supporting it for all the tools that, or I should say most of the tools that it's building today, right? So what's DSX, right? Data Science Experience. Data Science Experience, that's built upon, or it's part of the Watson Data Platform, and it provides that, multiple parallel processing, computing power, and processing, right? And it's a cloud-native application or a set of applications that, work together, seamlessly, for us as data scientists to make use of, and it kind of addresses all our needs. Anyone who is involved with data processing or analytics, this is the place to go, and we'll kind of know why this is the place to go, right? So, as far as data analysis or processing is concerned, by the way, how many of you are, already working and as a student here, working on different data science projects, or at work working on data science projects? How many of you? Let's see, almost all the hands raised. It's a good thing, right? So really, this would be the perfect time to know about DSX and how we can make use of, DSX in future. So any data processing and analysis, right? We can't just do in vacuum, especially if you're part of an organization. You are really doing it as part of a team. It's more of a team activity or a team sport, if you will, right? You cannot really do it in a vacuum saying, okay, I'm going to do all the job by myself. No. Not in a large organization, especially when you're dealing with tons and tons of data. That's now, we call it as big data. So that's many different roles that kind of come together, and the four main roles that we see in any organization that kind of come together for any data science or data analytics kind of projects are, data engineering, data science, business analysts, and the app developers, right? So to begin with, there are people, in the organization who kind of build that infrastructure for that data, right? That hardware, the software infrastructure that is required for the data to be stored and be made available for the users of the organization. Then there are these data engineers who are kind of, making sure that the right data is at the right place and is being made available to the right people at the right time, right? Basically, that's doing the governance piece, making sure that, this, as I said, the right data is available, there's the right access, being provided to the users, and also it adheres to the metadata, right? It makes sure that, the metadata is available for it, and the data that's coming in is transformed enough to be useful for the users of the organization. Then we have the business analyst, right? Very important role to play, right? Anyone here working as business analyst? Right, so we see a couple of hands there. So business analysts are the ones who will be really understanding the business problem, right? What is the business problem for the organization that they would like to solve? Or trying to see what kind of insights they could get from the data that would kind of enhance the capability of any organization. That's the basic role of business analyst. And then at some point, driving home the solution to the users, making sure that they get the solution that they're really looking for, that any organization could be looking for. So very important role to play there. Application developers, right? We could have a business problem. We could have someone, kind of lay out the problem for us, but there needs to be someone, the data engineers who would lay out the data for you, make sure it's available to you, but it has to be the application developers who would kind of really build the models and deploy those models, right? You need someone who's coding it, who's building those things, who knows the tool well, right? That's the application developers. And then comes the data scientist. Very important persona, very important role here to play, because they are the ones who really are, really talking to all these different roles and personas, if you will, to ensure that, they kind of know the problem well and provide the right solution to, for those business problems and to the business analysts, especially, and so that they're able to communicate the results back to the users of the organization. So a very important role to play, so that they need to know the data that will be used for data analysis or building the models, and make sure they are able to evaluate it. So they're talking to each of these roles here, to data engineers, to business analysts, and to the app developers. So right at the bottom of this slide, you see that this whole analytics process is really an iterative process here. It starts from ingesting the data from multiple data sources. It could be a database on the cloud, or some database on premises, or just flat files, right? It starts from ingesting the data, and from there it could be, you could take the data, deploy it for some reporting capabilities, or you could just put this data for long-term storage or persistence, like maybe in a Hadoop system or NoSQL, in kind of databases, or you could analyze that data, build your models, and then deploy it finally. And this would kind of go on. So once you evaluate it or get some more data, you would want to kind of continue with this process. It's not a one-time event or a thing. If you wanted to get it, in an iterative fashion, you'd be going through it. Then there's this important governance piece in there, right? We talked about that the data engineers are really also being the governors here, are doing the governance here, making sure the right data is available to the right people at the right time, at the right place. So that governance piece is always there in all these different phases, and like an oversight, if you will. Okay? So, talking about the tools, the IBM tools, there are multiple tools available, and especially at least one for each of these personas that we talked about. Like there's Bluemix Data Connect, that could be used by the data engineers for doing all the, doing the data ingestion or any kind of transformation that they knew, preliminary transformation that they need to do. Then there's this data science experience for the data scientists. We have the Watson Analytics, where you can, bring in your data, do some service, some discoveries, and I hope you must have, some of you who are already past, and you are in data 650 or, passed through 620 or 630, I'm sure you must have heard about and worked with Watson Analytics, right? Where you do all this data discoveries. Then there's Bluemix platform for app developers here. And Bluemix platform provides the infrastructure that you would need to build and deploy your models. So now for this different process, these different steps within your, the analysis process here, right, from ingestion, analyze, deploy, persist, there are all these tools could be used, multiple tools could be used for each of these phases. And it's not just the 4 tools, but there are some web services and services that could be used from the Bluemix platform, like streaming analytics, or the Watson machine learning that, that is kind of have come out, and there's some databases that you can make use of. So there's lots of other tools and utilities that could be used from your, data science or on this Watson data platform. So all these tools that we kind of, looked at or just talked about briefly are just nothing but the tailored experiences for making sure the users can collaborate with each other, right? They need to work seamlessly together. You don't want to duplicate your efforts, like going from Bluemix to, to data science experience, to Bluemix Data Connect. You want this all to be working seamlessly together. So they're really, and IBM has ensured that it basically gives you that seamless kind of experience, those tailored experiences for you to kind of, and not just the, the users, the personas to collaborate with each other, but also the data to be known to each of these areas. You don't want to kind of duplicate your efforts in any of these tools. So in any data science project, you would have all these 3 different pieces, mainly. You have, multiple inputs that could be coming in, the output that you'd be delivering, and the analysis piece here that you'd be doing here. And each of these 4 personas that we just talked about, they have a major role to play in one or more of these phases. For example, if you look at the data engineer that is marked by green here, has a major role to play in ingesting data, in transforming the data to a certain extent and shaping it up here. doing some of that governance piece, and besides ingesting data and also transforming it. If you look at for business analysts, it's marked in blue here. Now, business analyst has a very important role to play, especially in understanding the problem and the domain, knowing the metadata, knowing the business problem, knowing what they need to solve, or what insights they want to kind of have from this data. And right up to, and being part of the evaluation of the models as well, to make sure that it is really going to address the business problem they've kind of really come up with. And finally, communicating the results back to the users, right? That's where the biggest role of, and the major role for the business analyst to kind of communicate it back. Then we have the app developers who are involved, in yellow, as you can see here, involved a bit in the understanding the problem, but mostly in ingesting data, building the models, and deploying those models here. That's where they would be mainly involved. Then we have the data scientists, and if you look at the data scientist color here, you see that they're almost involved in all the different phases, right from knowing a little bit about the problem. The major time they would spend in exploring the data, in exploration of data, understanding the data, in transforming the data, in creating and building of the different models here, because they would be providing that intelligence that the app developers need to know as to what kind of model needs to be built, what kind of evaluation, what kind of what kind of results they were really looking for from those models. So they would be involved with that, and of course helping the business analysts, with the communication of the results, right? They want to ensure that the business analysts are really providing the results in the right fashion, in the right format, in the right form. So that's where they would be also helping the the business analysts as well. Okay? So let me take a pause here and see if there are any questions before we go further. Are we good so far? Any questions? Okay. So what are some of the challenges of data scientists, right? I mean, many of you already, working towards being data scientists, or here who've been already working on data science projects. Some of the challenges are keeping up with many open source innovations, right? I mean, there's so many tools out there, right? Which one really do you make use of? And how do you really, evaluate those tools that could be applied and could apply to your projects? That would be very helpful for your projects. Then finding out the big dilemma is which programming language to use. We have R, we have Python, we have, Java or Scala or SQL. Which ones are we really going to make use of? And that is really going to be, helping me with the project. Difficult to collaborate across different tool sets and environments, right? If you're using multiple tools, are they really speaking with each other? Are they really going to collaborate and ensure that what I do in one tool, I do not duplicate that in other tools? Lack of metadata. Real big problem here. If data scientist just goes in and says, okay, I've got the data, let me just put into build a model and just deploy it. Well, as you may have already heard about this phrase, garbage in, garbage out. If you really do not understand the problem, do not understand the data, and based on the metadata, then you're really not going to be able to provide the right results that the organization would be looking for, or what you would be really looking for. And finally, the difficulty to share this data products organizationally, right? You may be able to analyze the problem well, you may be able to build the model well, you may be able to, but now how do you really deploy it so that it's really going to be available to the right users of the organization? So these are all some of the pain points, right? Some of the real challenges that we as data scientists face today. And one tool that really addresses many of these challenges and overcomes the limitation is IBM Data Science Experience. It's bringing all the tools together that you would need as a data scientist to process your data, to analyze the data. It's an environment that brings together everything that a data scientist needs. It includes the most popular open source tools. We talked about R, we talked about Python, we talked about SQL. All the tools are kind of available under one huge umbrella, under one huge platform. It's like a one-stop shop, right? So the data science experience really has these three different areas: learn, create, collaborate, right? Now, data science experience is not just providing you those capabilities to build the models and evaluate your models and get done with it, right? They want you to even learn on the same platform. You really don't have to go elsewhere to say, okay, I want to learn about data science experience. Where do I go? Which place, which institute do I go to? Or which website do I go to? No, it's all up here. They're ensuring that all that information that you would need to know about data science experience, even to the extent that they take it further to say, okay, how about some of the nuances of data science? How about knowing a little bit about some of the concepts of data science? So there's kind of building that whole learning environment also as part of the data science experience. Second is to create. This is the core piece there, which is providing you that capability to build those models and deploy it, or build those insights that you're really looking for. And finally, but another important piece in there, or the area, is collaborate, right? I mean, we could all say, we just mentioned that it's a team event, team activity, or team sport within your organization with different roles. But at times, you as data scientists really want to evaluate in some way, your models with, by collaborating with other data scientists, maybe in a similar organizations, maybe, it could be other data scientists that maybe a group that you're part of, that you want them to really take a look at your projects, provide some suggestions, comment on what you're doing, and at times even just invite them to be part of that project, and really it's like crowdsourcing. You want to invite folks to say, okay, can you help me on this project? I want you to even build this project with me. So they're bringing these three important areas as part of data science experience. So the other way to or the three ways that they're really overcoming this, the challenges, or really addressing those challenges, are through community, open source, and IBM added value. So as I was saying, that it provides that learning environment. It provides that community to use. It provides the tutorials, the data sets that may be required for you to practice. They will be providing some articles and papers if you want to enhance your data science knowledge. They're also providing those articles and papers that would be really helpful. They provide you. There's also a chat box on this platform that will enable you to talk to other data scientists, or get their feedback, get their comments. And this chat box is also manned by the DSX technicians, the techs, that in case you run into some technical difficulty, they will be able to help you out with that. It helps you to connect with other data scientists, so you can share the work, maybe invite them to do some work with you, and so on. So it's kind of building that community here. You're not just on your own doing it, unless you really want to do it this way. But in case you want to really evaluate that, or get some feedback, some comments from others. So then it provides the other way it kind of overcomes that is providing those open source tools, right? So you could be, you want to code in Scala, you want to code in Python or R or SQL. It's right there. You can use it all. It's not just making use of only some popular or only one or two tools. It has got all those programming languages that you may be familiar with. They're providing the Jupyter notebooks and environment. We'll talk about that very soon, about the notebooks. A couple of slides there. I'll kind of walk you through that in case you haven't heard about or have not familiar with the Jupyter notebooks. But it's a wonderful environment where you're not just coding, but you're also putting in your comments, or putting in all the information that you need as to how you're doing your analysis step by step. So it's a nice environment that you could use to code. Then there's RStudio and Shiny, and building the Shiny web applications. If you're someone who's very familiar with RStudio and R language, well, that is also in part of the cloud environment. You really don't have to download and install, although it's not that difficult to install. I know it's an easy task, but the fact that at some point when you will want to kind of collaborate with others, you really don't have to be sharing files from R programs. It's all up there. It's right up there. So you just need to take advantage of the fact that even the simplest of tasks that, installing of RStudio is already there with some packages already installed. You can add some more packages if you'd like based on your projects. And then you can also build that shiny web application that is also kind of becoming very popular if you are an R language user or RStudio user. Of course, this is all being driven by Apache Spark, and we'll talk about some of the motivation behind Apache Spark. And there are some libraries that are also available in addition as well. Now, there's some value added by IBM by providing certain services and certain functionalities, certain packages, some services like IBM Machine Learning, SPSS Modeler, if you're familiar with SPSS, kind of where you have like a canvas to draw and build your models and put up your entire process, and you can collaborate with others using this canvas. IBM Machine Learning is where you don't have to really do much of coding there. In an automated fashion, it could build a model and deploy the models for you. They are kind of in gray here, and the only reason being they were in beta not too long ago, but now they're in GA. So that's the reason why they're in a different color. But otherwise, everything it's really a good service to try out and see how it would help you to kind of build your models without doing much coding. Then this prescriptive analytics, in case you're familiar with decision optimization, like the CPLEX or the linear model building for decision optimization, it also allows you to do that. There's projects and version control, right? So if you have a project that we have to maintain the version control for all the code and the files that you have in there, you can have version control as part of it's an inbuilt version control system it has. But other than that, it also can be integrated with GitHub. And I'll kind of show you a slide for how you can integrate it with GitHub as well. And of course, this is, as I said, it's using the managed Spark service. You really don't have to configure Spark. Everything is like plug and play. You just get to your projects, and the Spark service is like the OS, which everything is going to run upon, and you don't have to really do any kind of configuration for it as well. It's directly kind of made available to you. So some of the components, the major data science components that you will get to see as soon as you log on to Data Science Experience, the components that you will really work with is the first one that is kind of more visual is the project. You basically create a project. You will be then, having some data assets as part of this project, which is basically, having connections to some databases that may not be part of DSX, but, residing somewhere on the cloud, or it could be just flat files, or you may have a database in premises that you will want to bring it into your project, onto this DSX platform. So you have your data assets, you have your analytic assets, such as the notebooks that we just talked about, the Jupyter notebooks. And this all can be collaborated. And once you have it in your notebooks, it can be collaborated with others. And when the collaboration could be at 3 different levels. You can make someone the administrator, running the show along with you. You can have someone as the editors, they can work with you, they can edit your files. And you could have someone as just viewers, right? Hey, just view this file, view my analysis, and just, share your comments with me. So for that, you have the collaborators. So you have a way to even add collaboration for each of the assets that you have on your project, be it notebooks, be it even you can create templates. If you know there are certain things that are going to be repeated for multiple projects, you could create template notebooks here for bringing in your data, connecting with your data, and so on. So those templates could also be built here. The runtime environment, as I said, is completely Spark-based, and we'll just talk very briefly about what's the motivation behind it, but it's based on Spark. Other than that, there are some additional web services and some based on cloud and some cloudless, like decision optimization, as we just briefly talked about. We have tools for visualization, like we have the Jupyter notebooks, where you could do your analysis just step by step. It's not like getting a Java or a program or a C++ program where you have to write the entire code, and then to run that code, you need to compile and run it all completely, the entire code. In this case, you can just, step by step, for each cell, and we'll look at it very shortly once we get into the demo piece. We'll look at how step by step you can comment your code as well as run your code line by line so that you can see each step of your analysis. Or if you are just an RStudio user and it's your favorite tool, you also already have the inbuilt RStudio in it as well. So just looking at some of these slides here, like, for each of these components, so I was just talking about the projects. The projects are, the setup in a way that you could have all your different personas here in the organization get access to one or more of your projects. And each project, in turn, can be accessing different data assets here, which are you can kind of build these data assets within your project, and this data asset could be really accessing data for one or more sources here. It could be bringing data from a data lake or databases outside, in some premises you have live connections, or you're just bringing in your flat files in. So it allows different users to share the set of assets. It enables you to collaborate and manage your notebooks. It has 3 different levels of rights that we just talked about. So that's about projects in general. Then I was just talking about the collaboration. When you get to this page here about the projects, once you create a project in Data Science Experience, you get a way, you'll see that there's this collaborators piece in there and for each of these data assets or any of these assets within your project, you can really have this shared amongst your multiple collaborators, multiple users in the organization. It could be well collaborated. So it is as simple as add new collaborator. You type in their name or email address. Make sure they should be a licensed user, by the way. If they're not the licensed user, they're not going to be able to collaborate. But there's one way that you can collaborate outside of DSX, and I will get to that soon. So there you can add a collaborator. You can add them as a viewer, as an editor, or as an administrator. So this is the way you can even share outside of DSX. It has got it can be integrated with GitHub. So you can have your version control run by GitHub by integrating with GitHub. You can have your files on GitHub, and maybe you can share it on GitHub, right? You can fork your projects on GitHub. You can share them, so you can have all that version control also going. So there's this integration with GitHub as well. And finally, this is community card. So once you log into Data Science Experience and you click on the community area, you'd see that it kind of displays a list of basketball type cards. And these cards are nothing but you can click on either of them. So it's a nice visual view of what's available for learning purposes or as tutorials or for reading purposes, enhancing your data science experience or your data science learning. Everything is right out here. There are notebooks, there are data sets available, there are like articles, there are articles available. So everything is up here as soon as you log into Data Science Experience. So what's a notebook? Is everyone here familiar with the notebooks here, by the way? Is anyone here who's not familiar with the notebook? Let me ask that. Everyone is, right? So I really don't need to kind of go on to talking a lot more about the notebook, which is nothing but, as I said, just a digital equivalent of notebook. But the only thing, as I said, the biggest advantage that you get by using Jupyter Notebooks is going through an analysis step by step, running your analysis step by step, and commenting on the same place, which I know many other programming languages do offer, but the way that it can be offered using the markup languages, it really comes out very well. So we'll kind of skip this because everybody's familiar, but okay, one thing to keep in mind is that it's running on Spark. That's huge, and we'll see why really it's huge. So it uses the IBM's managed services to, first of all, to make use of all the data sources. So you can link your data sources, and these are different data sources, whether they are on IBM Cloud, whether they are on public cloud, or cloud apps elsewhere, or on-premises databases. They could all be, kind linked in and brought into your notebook very seamlessly. There's not much of coding really required to get in your data into these notebooks. And there's this Sparkling Data API, which is just also available for you to shape your data or do some visualization. It's a nice API to make use of while you are transforming your data and you want to really visualize it at the same time while you're doing it, right? So there's a nice API that's available. So now getting on to, you're almost there with this presentation, so we'll do much more hands-on now after just in few minutes. So we'll just go through one more piece, just a couple more pieces actually, so just 3 or 4 more slides here. But let me pause in case there are any questions. Any questions up to this point? Is everybody able to follow? Going too fast? You need to kind of go back and go through, walk through anything else, anything that we've kind of gone through at this point? Okay, very good. So the main motivation for Apache Spark. Now, as soon as it comes to discussion about Hadoop or Spark, people say, yes, there are many Hadoop installations out there that really does a great job for all the big data and providing that object storage. But one area, a couple of areas where Hadoop has got issues is kind of long-term persistence. That's one. When it is anything data stored for a very long term, that's one issue. The second is the processing, right? You can have all the data in there, but when it comes to processing that data, you see that it has got a very slow disk I/O. So what Spark does, it kind of overcomes this, and it provides you that speed that's required. We are now at a point where we are not just bringing in data once, taking a snapshot and building analytics. We are getting streams of data. There's tons and tons of data that is being brought in, and now almost every second, every minute, or every hour that an organization is bringing in, that would need this speed to process it. It's just not about storing the data, it's about processing the data as well at the fastest time, so that you can react to those events that are happening that the organization would be really looking for. What is the social media really talking about, the products that you developed, or anything that your organization is really working? What is being talked about? What is being texted? What is being emailed back and forth? All that data that's kind of bringing in, all that streaming data. Or if you're in a weather station, you're getting all this weather-related data. How do you really come up with, you kind of process it and come up with results as quickly as possible? That's where Spark comes into play. That's where the main advantage of Spark is. Also, the other one thing that Spark does not really do well, or it's not too popular about, is its storage, right? And so IBM, this IBM data science platform is making use of this object storage. As a matter of fact, they have gone one step ahead, and now it's in beta called the Cloud Object Data Storage. But object storage, in the simplest form, is that any data element that is created, it's created as an object and stored at some place. It is not stored in files. And as Elena was just giving us a very good example, she just gave it to them about being a valet parking. You go to a valet parking, you just give your keys, you go away, you come back, and when you need the car, and you get the keys back, you don't have to know where your car is parked, right? It's all done. It's all that being done by the person who is managing the valet parking. So it's very simple, as simple as that. You have your data, it gets into some storage, and it's being brought back in the fastest time. And that's what the object storage is doing. So it's kind of a different kind of storage that really helps you to do all that faster ingestion and processing as well. So just a little bit about object storage: inexpensive, scalable, self-healing, resilient. It's a flat edge. Objects exist at the same level and has a drag and drop upload, and it provides a Swift API for programmatic access. So as I said, there's not much you really have to do from a coding perspective when it comes to storing your data, bringing your data onto notebooks, and processing it. Okay, so this is just a couple of slides on the RStudio, which is, a built-in experience. And it's RStudio, if you look at the screen, which is really a snapshot from that DSX environment, very similar to the installations that you may have on your laptop. It's exactly, very the same experience that you would have. So you'd also, just a slide here to say that, you can also create your Shiny web applications at the same time. All right, so with that, as I promised, we have to kind of just go through a few slides. So we're almost there to the main part of our presentation today, and that is to do some hands-on. So before we get to that, I'm going to invite Dr. Gorcheva to kind of tell us a little bit about streaming analytics, one of the services that we are going to make use of today. It's becoming very popular. The data is kind of coming in very quickly, and how do we really process? Where is it being used? So please welcome Dr. Gorcheva again.
Okay, just few words. So we are clear what we are going to do now. Up to now, we get the introduction to very powerful tool in the hands of data analysts. It's like a big store, which in one stop you can get everything as a data scientist. In order to get some hands-on, we have to do application in some area. One very hot topic today with the big amount of data and still growing is stream analytics. Why? Because when the size of data grows so much, it's very important. In many companies, they start accumulating data, but this data just sits. And this sitting data without insight has no value. One way to get value of this big data is to stream. The change in the data. Stream is like the normal concept of stream. You can think about data stream of something which is going continuously changing in time. And you can do a sample like Windows and take a sample in certain time. So from business perspective, many companies have found the value to do stream analytics. And the stream analytics is going to give you the insight of big data, not about what happened yesterday on this storage or the week before of this storage data, but in real-time insight. And competitively, for any company, this is of high value. At the end of the day, as a data scientist, data analyst, your work must have value. And the main goal of our job as a data scientist, a data analyst, to find value of the data. So just a few examples. Everyone knows Walmart. The inventory of Walmart with the number of store and customers serving constantly is changing a stream of data. So Walmart tackle on this stream analytics of their inventory, and actually what they are doing is using techniques. They explore 3 different providers. They explore, if I remember, a Sparkstorm, and the other option they explore and they adopted was the stream analytics service of IBM, because they did like comparing 3 different providers, what is going to work from them from performance point of view in tackling what is inventory, or in general terms, supply chain. And they adopted the stream analytics of IBM, the one we are going to practice today. Another example I don't want to miss, there is almost in every area today, businesses which want to get advantage of big data, they are going to stream analytics to get analytics in real time, which is to give them a competitive advantage. Something of very value is in healthcare. In healthcare, there is intensive patient monitoring, blood pressure or different indicator, and collecting them as a stream of data so that the treatment is tackled constantly. This is tendency today going in real in healthcare. In other area, also important is in, let's say, in traffic, a smart city. Let's say, a stream of car, monitoring the stream of car, you can monitor and detect car accidents which are going to permit the city to divert the traffic in let's say, in major pathway of driving the car. And there is almost in any area today, people are just inventive about the possibility to use this already affordable, let's say, affordable services provided in the cloud to do stream analytics. And many are taking this as a task. So with no more, we are going to do, as far as I remember, Elena, 2 examples today?
Yeah, we'll start with one, and if we get through that, we'll definitely get into the second one as well.
Okay, so I don't know who is going to start,
Sure.
but as you know, Elena is going to do the demo with you and helping you to get, let's say, grasp of what we were talking about. Not just now it's in the real time. Not real time stream analytics, real time learning.
Okay, so has everyone registered to IBM Bluemix, by the way? Is everybody in? Good? No issues? Okay, so Elena is going to walk you through, yes. Any issues with the registration? Okay, so can we move forward now? So everybody's into Bluemix, and now Yelena is going to help you kind of get on to how do you get on to it, adding a service on the IBM Bluemix platform, and then from there go to data science experience. So she's going to walk you through that, and until we get to a point where the notebook that we are going to make use of for using this streaming analytics, a very simple example we are going to start with. Okay, so over to Yelena.
All right, can you guys hear me? Okay, so here we are in Bluemix right now, and we've got the catalog. So that's basically a list of services, and if you look in the left panel here, the services are divided into the categories. You make sure that you choose data analytics, right? So within data analytics, this is a streaming analytics application that we're going to use. So what you need to do is you need to click on it first, and you have to add an application to your dashboard, right? So you're looking at the catalog, but in order to launch an application, it must be added on your added to your dashboard. Now, if you scroll down, you want to make sure that you are selecting the light plan, right? Otherwise, the rest of the remaining plans are not free. You want to be using the free one, but as always, you want to read the terms of service. Okay? So now let's go ahead and hit create. And it's going to take a few minutes, depending on how fast your internet connection speed. But what it's doing right now is that it's adding a service to your dashboard. So basically, we have a catalog, and dashboard is like a little area where it lists the services that you have on your account. And you may have up to 10 services added at the same time. Oh?
No, it did.
Uh-oh.
It's successful.
Okay. Okay. Let me close this out.
No, this will refresh.
Okay. Right. Yes. Exactly. Okay. So, yes. So let's go back.
To see if everyone okay.
But that's okay. We can go to the dashboard.
I don't think it did it because I saw the error.
And the dashboard. Bottom up.
Oh, okay. Okay, so what I think we need to show it again. Ooh, that's what we want. Okay, so I can show you again. Watch here. I'm in the catalog right now, right? And
Is everybody okay with getting onto the catalog? Everybody good? All right. Okay. We'll add the streaming analytics service now.
right. So what you need to do is you have to go to data analytics. Well, you have several options here. You can scroll through, or you can just select the category that you want to look at, right? And now what you need to do is you need to find the streaming analytics. So,
Go all the way to the bottom.
yes. And you see that it's right in the middle. So you want to click on this, and it will open the service create page. Make sure that you have a light version selected, right? Okay, so that's a free version, and it won't charge you. Now you're going to hit create. And now it's going to take about a few minutes for the service to be added to your dashboard. Dashboard is your little area. Okay. And that's mainly how you would add any service that you would like to use. Any service from the catalog, you would just click on it. You would open the create page, and then you would read through the terms, the agreement, and after that, you want to, yes, it's an error. And you sure you're still within the limited number of services? Okay.
It's just timing out.
Yes, it's timing out. Well, this is what's happening. It's because of the bandwidth. So when you work on this application, you want to make sure you have a good internet connection speed, and you want to make sure that, try again. You want to make sure that nobody is streaming anything, like games or cartoons from online. Yeah. So any success, guys, is getting to catalog?
Anybody able to add streaming analytics? Oh, okay.
Okay.
That's cool.
Ah, okay. So we can, you mean close the... Okay.
Maybe just add, remove this.
So go ahead.
Yeah.
Go ahead, it's your login. All right? So while he's doing that, yes. Right. Yeah. So sometimes you really need to refresh the page. Well, let me see. Is it in there?
No, it's not there.
It's not?
I'm just deleting some service in case.
Okay. Oh, yeah, it's because... Oh, wait, no, you have 10. You're still within the limits. Browser?
Yeah.
Can you have you
Yeah,
restart?
sure,
You might
sure.
restart the browser. Yes. Let's try that, please. So how many of you are still adding the service? You're still adding, right? Yeah. I was able to edit that.
Okay.
Okay, so did you restart the browser?
No, I'm just logging out.
Log out completely, and then log back in. Yes, so go back. You may want to close. Oh no, you can't close the browser because of the WebEx.
Yeah.
No. Well, how about if you try a different browser? Yeah. Oh, and speaking of the browser, I think Google Chrome might be my first preference at least. Sometimes, if it does not work in one browser, the solution is to try any other browser, but Google Chrome is my preference. Yeah. So again, keep in mind this is a cloud application. You want to have a good bandwidth, and yeah. So did it add?
No, I'm just adding it there. So going to data analytics, and then streaming analytics. Okay.
Yes, click on create. So once you have the service added, there will be a page that has credentials. You would need to copy these credentials because, well, what will happen is when you add the notebook to data science experience, you would have to enter those credentials. Yeah.
No, it's not. It's timed out again.
Oh, okay, it's timing out.
Try one more time in a different browser. I'll log out and get into a different browser. Yeah. Yeah, I'll try it one more time with the other browser.
Yeah. Okay, so try.
Completely. Try with Firefox.
Yeah, we can try Firefox. Login.
Just the flow, yeah.
Dialog. Okay. Login. Yeah. And then create. I have it edit in my PC.
Oh, is it? Okay. Let's see. Oh, yeah. You already have it, right? Okay, you already added it. Okay.
All right. I already added it on my account, so we can try that. Are you logged out? Huh? What is it? Log in. All right. Oh. Oh.
Okay.
Basically, the issue is because today is the 13th.
That makes sense now. Absolutely. So where are you?
No. It's showing me all my subscriptions for some reason. Oh, mama. Okay.
Console.
No. All right. We're getting somewhere. So, basically, this is my dashboard. This is a list of services that I currently have. And what I need to do is I need to find the service, and this is streaming analytics is here, right? So, now what I'm going to do is I'm going to click on this. All right. There are several steps that we need to take here. We need to create credentials. Why? It's because when we run the notebook from Data Science Experience, we have to have a way to connect to applications that collect the data, right? So over here, this pop-up says that our service has already started. The service already running. Okay. What happened?
Yeah, it started.
It started. So now we have to go to service credentials. Huh? We have to go to the service credentials. All right. And delete. Okay. This is what you will see when you just add the service. You don't have credentials. You need to add. You need to generate one. Right? When you just add the service, see the service credentials? You have to generate your credentials, because when you use the notebook in Data Science Experience, you have to have a way to connect to applications that collect the data. So I'm going to hit on new credential, and I'm just going to keep it as is, credentials 1, and I'm going to hit add. Okay.
Yeah, working.
Basically what I did was I logged into my account.
Well, we just find out that there is technical problem in the U.S. Other parts of the world are okay. United Kingdom, Europe, Sydney, they are okay. But here we have problem with this.
Yes, but
so it's not going to be stable.
But the good news are some good news. I already had it added. I have it added to my account, so that's a good news. So that I can show you what it looks like, at least on this dashboard here, right? So you're going to know how to add the credentials. Well, we're going to do our best. Now we're going to go to manage, right?
Did you copy the credentials?
I have not yet.
Okay.
But, okay, so should I click on launch?
Yeah, no, just click on
Oh, okay.
credentials.
Okay,
Go to
so
launch.
go into service credentials, and this is what you need to do to copy. You click on this arrow. You can highlight this whole thing and to just put on your, you can do this, Control A. Oh, no, that's not what you want to do. Or you can click here.
Yeah.
I prefer clicking here, and it's going to say copied. Now what we need to do is we have to go to the data science experience, right?
Yeah.
No? Okay. So now I have to do the sign in, right?
Yes.
Yes. And usually if you sign in Bluemix, you just click sign in here and it kind of finds your login and password. Okay, so now this is a community page that Linesh was talking about a little bit earlier. And what you have here, you have articles, you have some sample data sets, you have some sample notebooks, and tutorials. And in fact, I would recommend at your leisure, go in and watch as many tutorials as you can. All right? So now we want to, so in order to see just notebooks, you click on notebooks, and then you can do the search. Right? If I search on streaming, it's going to give me these 3 notebooks on the streaming analytics. Right? So, do you think I can just go in and use one? Do you think I can just click and run it? Is it going to work? I don't think so. It won't because it's right now read-only. So, any idea what I need to do to make it work? What do I need to create? What do I need to create? A project. Excellent. Somebody was paying attention. All right. So, to do that.
Is everybody here, by the way? Are you going fast? Need to slow down? Is everybody here up to data science experience? You're able to follow that we came from Bluemix platform to data science experience. And when you click on data science experience with sign in, you are able to sign in automatically because you are already signed into Bluemix. You see the integration there. See how these applications are talking to each other. You logged into one, you're straight logged into another. Okay? And this is the data science experience platform that we are in right now. Anyone who's not yet, not at this point yet? Is everybody good? All right.
No?
Okay, all right.
So now, this is what I'm going to do. See this tab here? Projects, Tool, Data Services, and Community. I'm going to select Projects. I'm going to hit View All Projects. And it's going to list what projects I have on my account, if any, right? So now what I'm going to do, I'm going to create a brand new project. To do that, I click New Project here. And I'm going to give it a name, and I'm going to call it Streaming. All right? If I want to, I can go ahead and enter a brief description. All right? So now, what I need to do is, as Linesh explained, it's running, it's using the Spark service. So I want to make sure I have a Spark service here selected. And I believe we can leave it as is because we're not using the object storage. We're not uploading the
yeah, we're
file.
not using, but it's by default, the object storage is already chosen.
Yes. Create. In other words, we are not uploading the data file. We are using the streaming application to collect the data. So now here is a project project overview page, it's showing you how many, well, basically an asset is a notebook or a data set or a model, anything that is contained in your project. Right now, I don't have anything because I just created a new project. Collaborators, it's just me, all right? Here you see the date when the project was created, and here you see the available storage. So you are limited to 5 gigabytes per project. So now I'm going to click on the asset, and I'll show you several sections in here. If you were to upload the data set from your PC, they would have shown up in this section, data assets. If you were going to upload the notebook from the URL or from your local file, local PC, or create a brand new notebook from scratch, they would show up in the notebook section, right? But today we're going to do something different instead. We're going to go to community, and we're going to save this notebook that we were just looking at, and I'll show you we're going to save it as a copy. So let's watch again. Community. I filter out. I want to see only notebooks. And in here, I can just search. It's because I know what I'm looking for, so I can just put in streaming. And which one would you like to do?
Data model.
This one.
Yeah.
First one.
I'm sorry.
The middle one.
Middle one.
All right. So let me show you the trick here. First of all, I have to click on the notebook to open it, right? And right now, this is in a view-only mode, so I cannot make any modification because this notebook belongs to the community. It's not my local copy. What I need to do now is I'm going to create my copy, and I'm going to put that copy in my project, right? And I'm going to work from that copy. So if you see here, this button right here, it's copy. What that will do is it will save a copy of this notebook into my project. So here's a drop down, and I created a separate project called streaming, right? So it already picked up the Spark service for me, and I'm going to hit create notebook. So there are actually 4 ways to create notebooks. You can upload a file, you can create it from the web page, you can create brand new, or you can save the sample notebook in community as a copy. All right? So right now, the Apache Spark is starting, and as you were discussing earlier today, the notebooks contains the cells. So this cell that gets highlighted right now, this is non-executable cell. It has text in it, but there is no actual executable code, right? So now, if you notice that all executable cells are numbered, so in means that it's an executable cell, and it's an executable cell number 1, right? So let's go up. And we start running the cells from the top. But when I run this cell, nothing will happen because it doesn't have any executable code. I can just hit run, or I can just skip it. But to run a cell, see this? This is a play button. That's one way to do it. Play, right? So right now, what we're going to do is, this is a library that is used to read the data from the streaming application. So let's hope that it will work. Let's run. If not, then we will focus on conceptually. So basically, when the code is still running, you will see this little asterisk. An asterisk indicates that the code is still running, right? And yep, slow. Well, just pretend. We can pretend that it worked as expected, right? That would have imported the library. And then what we would need to do is, we already did this step, right? This is a service, that we added to Bluemix account. Here, when I run this, if I ran this cell, I would have been prompted to enter the service name, which would have been streaming 1, right? And then at the next step, I would be prompted to enter my credentials. So at this step, this is a step where I would be connected to the application that collects data. In here, we are just collecting the data, right? We're running the application to get our data, right? And after that...
So in this case, in this particular step here, what is being done because of, what we are doing here is basically creating a data set within the notebook itself. We are creating a sample data set. So as you notice here, what is being done, it's creating a sample data set, and all it's doing it is taking in a sample of like 100 samples of numbers, X values between 20 and 100. So that's what this linspace is doing. What Y is doing, Y values, is based on some formula. It is creating an array for Y values. So we are creating some X values and we are creating some Y values. So we'll use X as a predictors and Y as our target. So that's what we are creating it here in this particular space. And then what we are doing is we are now plotting whatever the X and Y values are as a scatter plot. So that's what we'll see.
Yeah, but in this specific application, X values are the temperatures. And we are trying to predict if the station reading the temperature is accurate. Right? That's what it's doing right now.
So X is the engine temperature and Y is the probability of failure. So Y values are all going to be between 0 and 1. Kind of predict this, the probability, and engine temperature is going to be some value between 20 and 100. Okay? So this is what it is showing here in the scatter plot. All the X values are the engine temperature here on the X-axis. Y-axis is the probability of failure. And so this is scatter plot, which is showing you what's the data set like. Okay?
And then when you scroll down,
then what we're doing here is creating a model for the sample data. We created the data, and now we want to create something called as neural net. I'm sure everybody's kind of familiar with the neural network, and for that we are creating a shortcut way of building a network. It's a feed-forward network called with the building this. We are building a network which will have one input. It will have 3 hidden layers, which consisting of 100 nodes, and then we will have 1 output. And there's a bias being added to it, with a hint, kind of telling you that it would be back propagation kind of a network, where we'll be feeding the errors back to correct our output, right? So it's kind of building that network with this, and then what we are doing is now we are creating a data set of the training. So we're creating the training data, which is nothing but we are taking our X values, we are taking our Y values, we are making a supervised data set that could then be fed into this trainer. So we are creating a trainer object, which is nothing but we are taking this neural network and we are providing it to the backward propagation trainer, and which is going to help us train this model. So we are training the model, and then what we are doing is, as we are training it, we are displaying the model in a plot on each iteration, like how the plot is going to be created for that model. So as you see here, when you run it in real time, you'll see this lines kind of flicker between some of the values, then it will kind of held constant at one point. The reason it goes constant is it goes through all 100 samples. It goes through all 100 samples, and it creates with this the model here. So this was the actual data, the dots here, and this is the model that it created and the prediction of the Y value for the dots that were created, for the X value. Okay? So, is everybody okay so far? What we have done in the notebook, we created a sample data, we created a model, a neural network model, and then based on that, we just plotted that neural network model with the prediction that it came up with. Okay?
let's just imagine that when I hit play, it ran. Let's just imagine, all right? All right. So this is the next one.
So now we are doing using the model in a real-time streaming application. So yes, there's a question.
Mm-hmm. You would have been prompted.
Yeah, when you get prompted, you just copy the entire credentials as is with that copy button and just paste it wherever it asks for that input. Wherever that box you see for the input, you just paste it over there. Just Control V, everything that you copied.
Mm-hmm.
You don't need to delete or add anything or edit it there. Okay?
Yep.
All right, so now we looked at a model that we just had 100 values. What if the data is kind of coming in constantly, right? So we have kind of now trying to put it into a streaming application. We're taking this model, we'll use this model to kind of address the data that's going to come in, continuously. So what we are doing here, we are creating this class called periodic source, which what it's doing here is, unless it is stopped, it's in a while loop here. It's an infinite loop that's going to generate X values between 20 and 100, right? That's what this piece of code is doing. And what the other piece of code is doing is, it runs the neural network on those X values. So as soon as it sees the X values, based on the model that you've created, it's going to provide the Y prediction, the Y predicted value. So that's what these two classes in Python that it's doing. Okay? So now that we are ready, we will kind of go and define the streaming application. Yeah, go ahead.
Let's just assume that it ran as expected. Does it scroll down?
So yeah. So in this case here, we're kind of seeing that we're using some of the the classes or the packages that are available for streams, and we are creating an operator. We are creating a class object for periodic source. We are taking this neural net model, the network model that we created. We're creating the graph here, and you're kind of publishing this stream here. So some statements here that could be used as a template, but all it's doing here is now we want to take this model, put it into a streaming application, and it's going to address all the X values. So that's pretty much the gist of this particular cell.
And this is the output, basically. See that?
So what it does, it basically, it's starting the streaming analytics. So it will take few seconds to a minute here to get to this point where it says this last statement here, streaming analytics service, your service name, and it will give you some information here, and finally you'll see the status as running. So this is what you really want to wait for. It's not going to, this cell is going to take some time, few seconds to few minutes, depending on your internet connection. And once this is running, now you kind of have put your model into the streaming application, waiting for those X values that are being randomly generated and throwing it at your model, right? And your model is constantly now going to come up with the Y values.
Oh, this is a view sample data.
So what we are doing here is basically, now that we've got the X values, we kind of predicted the Y values, we want to plot it and see what the output is and how we can, it's like kind of looking real time what the data is coming in and what the output prediction is. So once you've kind of gone through it, once you've kind of run through all these 100, it kind of is running for some few seconds. I think it was mapped for some 60 seconds or so. It runs for 60 seconds, takes in X values every second, and then it comes up with the Y values here. So what you see here are actually the dots. That is not really a line, but it's all the dots that it has predicted for the Y values that it has predicted for the X values. So we're just kind of plotting it here. So someone here who's looking at some machine failure is looking at, so there's going to be a lot of X values. You're getting all this machine temperature. Now you're hitting at certain Y values, some probability here, and maybe you have a certain mark saying if the probability of failure hits 40%, boom, okay, you want to take some action. So this is it's like right in front of you, like on a monitor here, you're watching it, and you say, okay, it has hit 40%, I'll take action. If not, I will just let it continue. You're constantly reading the temperature and constantly predicting its probability of failure. Okay? So that's pretty much what this notebook is. Okay? So it's a very simple streaming application. We did not really take a very complicated data. We just ran with whatever we built with the X and Y values, as simple as that. But it's easier to kind of now understand that if you're getting a data source, that how you're going to predict the Y values or the outcome, and then take that model, put it into a streaming application, and see how it would work for the other data set. Okay?
The other application that they have here is healthcare data. So basically the idea is collecting the vitals, analyzing the individual's vitals. So some of you, I overheard some of you are interested in the healthcare. So that's one for you. Right? So basically, at the bottom of the notebook, you have some references and you have some related notebooks.
Yeah,
the links to
the healthcare one is really a very interesting application. It's really taking some data there, some vitals that you would want to kind of observe, and it's kind of taking some data source, and based on the data source, it's kind of running through the Jupyter, an application. It's like basically building an application to read the vitals and kind of come up with what the outcome could be.
So should I hit it?
Yeah, you can just click to kind of show.
Well, yes, I can just click and we just look at the notebook. So this copy is also in the community page, right?
So when we searched for streaming, we saw 3 different notebooks there. There's one that we just picked up, the middle one, the data model, and there's another one for healthcare. There are 2 notebooks actually. They're same exact notebook. You want to pick the one which is in October 2017, the latest one. And it will just bring you to this notebook here. So it's a nice application that it builds. It's kind of showing you that it ingested some data called waveform data, which has got data related to ECG and some respiratory, some kind of vitals here, some numeric data about heart rate and pulse. It is kind of bringing in all that data into and doing some analytics, doing some analysis here based on this data, and then that analysis is being put in the model here, which is available through the Streams View server, and that's being brought into your Jupyter notebook, and you get a nice visualization, nice visual here of what's going on with the patient. So you're getting the patient data. It's constantly being, like you go into a hospital or someone in an operating room or something, and you have everything kind of going on. You're getting all the machine readings, and you want to kind of keep watching what reading it has, and based on that, take action. So this is exactly the similar application that's kind of built. In case this is showing that patient data is being fetched every second. Yeah, sure.
Yep. So here you see the table of contents. That's why you have to,
It's kind of going through a setup as part 1. You create the data feed. Instead of creating the data sample yourself, you're now getting some data feed. And then you're starting the streaming analytics service, which we're now familiar with, how to create a streaming service. Then you set up the access through the credentials. Once you get the credentials, now this is the little change from the previous notebook. You are now going to get the data feed and not really build the data yourself.
That one you have to go back to the streaming. So should I go and launch it? Where is it?
Right. I don't know if it's going to launch.
Well, we can always give it a try, or we can at least show how to do it.
Right. Or if that launching will help. I mean, we can always see the streaming.
Yes.
The page there. So while your application is running, the reason why we came to Bluemix to launch this, service button, or maybe check with the prevented this site from opening a pop-up. Can you click on it? Yeah. And say that allow. Yeah.
All right, right now it will reload.
So we were talking about the streaming, the application or the model being applied to streaming, but then what is really happening, right? In the streams, you really want to come to this console here that is kind of monitoring your streams here. So this is a nice console. So once you kind of get to know about, you kind of are setting something up in the stream, but then this is a console here which will kind of give you information about the number of jobs that are in the streaming application, the operators that are being taking place, that is part of your notebook, the streams, the number of streams you have created, and then some more information that kind of shows up on this console. So while your application is running, you can come to this console to kind of see as to what's happening with the streams, how many jobs are there, which operators for each of the jobs. It kind of nicely shows a graphical view here as well to kind of show you as to how many operators are there within your notebook, what kind of processing and analysis you're doing. It kind of shows you those different operators. And it kind of shows you the data streams that it is created. Like data going from one operator to another, that's one stream. The second to the third, that's the third stream. So it's kind of showing you all those different streams. So it will kind of add it up. So even if you're running one single notebook, that notebook itself, all the manipulation that you're doing within the notebook, that can come up to multiple streams of data because you're making the data kind of run through the different operators to get to your output.
And you have different dashboards here. See that? You can do the instance dashboard, jobs dashboard, and application dashboard. So that's basically the different ways to see the information. So now if we go back, right, so here it is, the start jobs, right? So we have to go to the application dashboard. Well, we're not sure if it will run, but
right.
We never know until we try. Okay. So now we are at the application dashboard, and we need to go back here. See this? Submit job. So that's what we need to click on.
You need to get this URL.
Oh.
For that data.
Oh, yeah. This one.
Right click.
So basically what you have to do is you have to copy, Control C. That's right. So now we're going to go here, and I'm going to hit the submit job. Oops. And it's going to prompt me for the URL. Oops.
No, next one.
Cancel. Yes, that's right. It's in here. I'm going to do that, and now I'm going to hit submit. Oh. Ah, okay, I see.
Oh, yeah.
Yes, it's the second one.
Yeah. Have to take the complete.
Oops. It's this one right here.
All the way up to
Yes.
HTTPS.
So you have two options here.
No, go up to HTTPS. Okay.
Oh, yeah.
This is complete, yeah.
You could download the file, and you could upload it from your PC, or you can just specify the URL.
So did everybody follow the difference between the previous notebook and why we are doing this step here? So in the previous notebook, we had the data created, and we created like a stream, right, within the notebook itself. Here, the stream of data, there's already an app that's created that is kind of generating the data. So now you're kind of saying, okay, we want to kind of add that as a stream of data that a notebook can access. That's the difference here.
And now we have prompted how many patients we want to analyze. Let's just do one. Okay. I'm going to click OK. So now we started our job.
It takes a few seconds.
Submitting, yes. You saw the message submitting?
Yeah, it just popped up right at the bottom of the page.
Right. And we could even look at see this successfully submitted. See this message? It means that the job submission was successful.
Right, there you go.
There we go, see?
So you see here, number of jobs, 1, the operators, there are 10 operators involved with this stream. So this whole package has now, it's doing this entire piece application here. Look at this different streams. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10 output. So there are 10 different streams here. So you see the streams of data. It is passing through, and it's kind of showing you where the data is being flowing and through which steps of analysis it is kind of flowing through. It's kind of all showing it up here on the chart, which was part of that console. We just kind of maximized that window for the console.
That's what I did because I wanted to make sure that people in the back can see it or people in the middle can see it, right? So let me minimize this. See, this is you can close.
Everything goes on green now.
Yes. So just want to make sure that you can see what he was showing. That's why. And let's see what else we've got here. See, these are different. You can look at
different way of looking at their dashboard.
Different views. Yes. So see that now. It shows that I have it running.
Yep. It's all green.
So now we go back to the
notebook.
Yep. So we did that, right? Now, next step, well, of course, we might not be able to run it, right?
If the stream application is running, then we should be good.
Oh, okay.
We can try.
What we had to do is we had to do this step first. There is a step where we had to install the package.
The package. Oh, yeah, this one here.
So let's see. Oh, no. There is one more thing that we have to do because this notebook is not in the edit mode. We have to save a copy.
Oh, okay.
Yeah, that's what we have to do, right?
Right. It should be part of your project.
Exactly, because we cannot make any changes because it's not ours. We always have to create our own local copy. And then we go create notebook. There we go. And remember, I created a project earlier today. So now the notebook should be in the edit mode because, there we go. So if you see those buttons right here, it means the notebook is in the edit mode. If you did not see that, and if the notebook is in your project, you would see a pencil over here. Then you would click on the pencil. You would see a pencil in here. You would need to click on the pencil to put it in the edit mode. So now we can run it. So just remember it, the notebook must be in your project. Now let's see. Well, what date is it today?
13.
Well. All right, so let's just assume, can we assume that it worked as expected? And notice that the notebook already comes with the output for you, right?
So it creates the data feed for us. So it's kind of, we're starting the streaming service. We're creating the data feed, which we just saw. We submitted a job, and we created that feed of data. So that data is now going to be constantly available for us to read.
Yep. And that's what you just saw. Oh, we could look at the metrics. Yep. So should I do?
Yeah, just keep going.
Yep. All right. Here.
So now we are kind of, creating that app, with all the, the topology and all that we kind of saw the last time. So it's just a template for us to kind of create this and have a nice, setup for the stream. So we're using the streams package. You're building that streaming application, and you are starting the service. So you need to wait until you see the status is running. And once you've done that, you're pretty much set to now look at the patient data, right? I mean, all it's doing is using some Python code to kind of say, okay, take this patient number 1, and you just kind of create the graphs. These are all the different graphs that need to be created with the package that we kind of installed here with pip that you saw initially that we were kind of still waiting on. It kind of provides us some functions here, some graphs that we can create directly based on it. So it's kind of a health-based package that we can really make use of. And once we've done through that, we can now kind of provide the data for our graph based on the output. So we are creating a data collector from the streams. So all it is doing is getting the tuple from the queue of data, and if the patient ID is equal to number 1, we start creating the graph. So it's kind of a loop, like it's a function that is kind of going in a loop to say how many patients did we really talk about. We took only 1 patient, and now we want to go through, get all the data, and then create all these graphs for that patient.
Yep.
So now it's coming to a point where you're almost through to kind of display the graph based on the data collection is done. You kind of got your, you ran your model against that data, and which was in the streams, and now you're going to, display the graphs based on, what the data, based on the data, what was the outcome of it through the model. So once you get that, it kind of gives you a nice chart here. It's based on the picture that you saw earlier. It shows all the different charts here that you would see in any, any patient room that you would see. Basically, all based on the vitals. It's going to tell you whether it's in red, whether it's something to really worry about, or things are normal.
And yes, we are at the end of notebook. Oops. Oh. Yeah, so we are at the end. And here, notice that it has a link to the notebooks that we looked at first. Right? And here are some resources that you want, if you want to learn more. Okay? If you want to learn more about the streams and so on. Yeah. So basically, just assume that you were able to run the notebook as expected. What you could also do is you could save all of the output as an HTML. You can do this. You can do I believe it's a download as, and then you can save. You can download the notebook, or you can also save the HTML file. Here, file, and then you would, anyhow, so now you would know you could download a copy of the notebook itself to your local PC, or you can also save this output as an HTML file, all right? And as I tried to show you, it's under the, go up, it's under the file, and here is download as, and there is an option to download it as HTML, all right? And it also, if you make any changes, it saves it for you. And now notice that, what is this? This is a comment, right? If this is a hashtag, anything that follows it, right, it's a comment. So you're documenting the code, what it does, right? Yeah. But did you guys follow?
Any questions? Yeah, if you have like your organizational data feed, or you can probably search within the resources that are provided if there are certain data feeds available for, you kind of practicing here. But yeah, I'm sure there are certain data feeds that could be available.
I may have seen the ones that it's on the traffic in New York. So it's like a traffic monitoring. That's another example.
That's some data feed available for that.
Or you could look, if you could find, it could be the stock price. It's another example of the streaming data. Basically, the data is continuous in time, right? So we did an example of the temperature. We did an example of vitals today.
So do try it out. If you're not able to get through it all completely here, you may want to just, step through the different cells, like, what they're really doing. We did not really touch upon the Python code, the code that was out there, but use it as a template. So, our goal here was not to, step through each line of the code, but to get an idea as to what each section of this notebook is really doing. And you can kind of mimic that, use it as a template, and use it for, the different apps that you may want to create. Any simple app based on, New York data, the traffic data that we have, or other, feeds that you may kind of get in future. But just mostly we kind of covered from a concept perspective. So any questions on that? Any questions on the web? Yes. You can use it, from the notebook. You can basically visualize, do a graph to display. Like the way we did it for the temperature data, like we got the X and the Y values. Yeah. So we basically got them in a scatter plot to kind of see what X and Y values were there. We were setting it up, but not the data from the streams, but basically in the notebook you can see it.
Yeah,
That's how you visualize it. Yeah.
If we were able to run it, you would have seen it here. Really?
Okay, good. Okay, excellent, guys. Okay. Okay.
Oh, okay.
All right, okay.
Okay.
I see. All right. Any questions from the web? No questions? All right. Can we also wrap then? I'll be good.
Oh, the references.
Oh, the references are going to be part of the deck that we shared at the end of the deck there. There are some references that are provided that may be useful. So if you can just go there, I can just quickly, or maybe the other tab.
This one?
The tab. Yep. Okay. So there are some references here, for the data science experience documentation, for the community. So there are some notebooks also here, some applications, and some couple of YouTube videos on streaming analytics that may be really helpful for you. So all these references are part of the presentation deck, okay? That will be shared with everyone. All right, folks? If no further questions, then we can call it a wrap. Thank you so much. Okay, good night, everyone.
Thank you, everyone.
Thank you.
Thank you, everyone. Thank you for attending. We have a little inconvenience that you were not able to add the service, but other than that, all the presentation is recorded and will be posted, so you can do this yourself. And this is, let's say, the convenience and the inconvenience of using services in the cloud. You never know when this service is not going to be available. And just we find out there is in our geographical area, a problem with the stream services. All other services were working. I tried everything else, just this one. So fortunate for the today presentation. But other than that, I think this is very helpful presentation. You can follow at your own paces and go back and forth and really, I would say, very valuable experience. Thank you, everyone, and of course, thank you to our wonderful presenters. Thank you so much. Thank you so much. And this is something from the ITS department, just to remember. This is a gift to remember.
Okay, thank you.
That's the most special. And special thank you to our always. I have no word to say it. She always preempts something which could happen. Always, because if not for her, we wouldn't be able today to do anything. You understand? Because she thinks about, sometimes I'm saying, why you think always something wrong is going to happen? Always. And she has a backup version for everything.
Yes, thank you.
Thank you, everyone.
Okay, good night.